My name is Christine G, and I am going to be going over this module 4, problem number 10, and you may need this number this will have to match up to your number 10. If it doesn't, then unfortunately your number 10 will be a little bit different. So let's take a look. Suppose the researcher is testing the hypothesis that the population proportion is equal to 0.3, and the alternative hypothesis is that the population proportion is greater than 0.3, and she finds the p-value to be 0.21. Explain what this means. Would she reject the null hypothesis? Why? Okay, so we've got some good information here, and I pulled this image so that we can take a look at it together. Let me see if I can. Oh, it is just doing things without me. I'm just trying to move it over. It's not letting me. Okay, well, you can see the entire image. So 0.21 would be, 5% would be 0.05, and 0.21 would be further this way. Let's say it's, I'm doing the arrow the wrong way. Let's say it's about here. It could be, yeah, let's just say it's about there. And 50% would be this half of the graph. So 21%, let me see if I can write. So let's say that this is, that's a lot. It's probably, this isn't a very accurate drawing, but 50% would be to the right, and so 21% would not be as much, but it would be more than the 5%, and that's kind of what I was trying to get at. So this is we could say, we call it the level of significance, this 5% or 0.05, and that's typically is a number that is used for the rejection region. So if we were way down here to the right, it would be our results, we would reject the null, but we're not. We're closer to the actual, and this would be population proportion instead of mu. But anyway, you get the idea, and so we are closer to here. And so we would not reject because we're not in the rejection region, which is in typically either in one of the, or in either of the tails. So hope that makes sense. So let's go ahead and take a look at choosing the correct explanation. So if the p-value for a particular test statistic is 0.21, that's what it says, 0.21. She expects results no more extreme than the test statistic. Actually, she expects results at least as extreme. So this wouldn't be right, not no more extreme. So here, let's take a look at this one, and they all start off with the exact same clause. If the p-value for a particular test statistic is 0.21, she expects results at least as extreme as the test statistic in about 21 of 100 samples if the null hypothesis is true. All right, that sounds right on track to me. Let's go ahead, and this says no more extreme, so that wouldn't be right. And then here it says exactly 21 of 100 samples. The 21 covers all of the area, so it could be it's not just that one 21. So I hope that makes sense. So let's go ahead and check that one and see what we get. Okay, that looks good. And then continue. So choose the correct conclusion below. Since the event is not unusual, she will reject the null hypothesis. You know, 21 out of 100 times is not unusual. But because it's not unusual, she's not going to reject the null. So this says she will reject the null. So since it is not unusual, she will not reject the null hypothesis. So, and let me pull up the picture. So if we're here, we're closer to the null hypothesis, which is the population proportion, which would be right here. We're closer to that. We're not down in the tail, way far away from the the population proportion. So we will not reject the null. So hope that makes sense. And if you have questions, you can always reach out to me. So since the event is not unusual, she will not reject the null. Perfect. All right. Well, thanks so much for watching. Have a great day and reach out anytime. Take care.